If you remember very well, in algebra, we had looked at, let's say, the components, okay, of an expression. So we said that we form the terms using, let's say, variables, okay, would use numbers, would use radicals, would use powers, okay. From there, we formed expressions, okay. After we formed expressions, we were able to form equations. And then these we had the ability to solve eventually, right? It's not different from trig. So we have functions, which is sine. We have, for example, we also have cosine, tangent, and things like that. Then we have the angles, okay? And then these, they help us to form the expressions, mostly in form of identities, okay? Once we form these, we should be able to form equations as well, okay? Maybe let's say sine theta is equal to 90, right? Sine theta is equal to 1, okay? Find this, okay? Find theta. So that would be an equation. So how do we form those equations? We form them using these. We form a term, we form the expression, then we form the equation that we can solve. But then the important thing to understand is that for us to be able to solve and give complete answers, we need to be able to understand conversion. We need to be able to understand signs of trig functions, the reference angles, and then we should be able to know the range and domain of these functions. But these actually help us to build the domain and range, the signs and the reference angles. So that's what we're going to focus on in these lessons. So conversion is usually between radians and degrees, right? And so the relationship is pi radians is equal to 180 degrees. And so we should be able to convert between these. So for example, if they give you 90, using the direct proportions or the direct relationship between these, we can say that 90 degrees is going to be pi over 2. Okay, pi over 2. If they give you 360 degrees and you have to convert it, you'll find that it's 2 pi. The conversion is easy. We did a number of examples earlier. You can go and check those videos. We're not going to spend so much time on this, but this is a relationship that we need to understand. Where we see pi, let's imagine 180 degrees. This is just a reminder. All right, so we go to sines. Sines normally use this mnemonic. It's called ASTC, which is all students. Sometimes, if you want to remember, all students, okay, take calculus, or you can say chemistry, whichever will make it easier for you to understand. You might have a subject, I don't know, you can put it there. Right, so what does it mean? It means that every function has got its sign in these quadrants. Right, so if I looked at sine theta, okay, this is sine theta. Sine theta here will be positive. Why is it positive? Because we're saying all functions in this are actually positive. This states that these are positive where they're mentioned. So here we're saying that it's all. Cosine theta here will be positive. Tan theta here will be positive, right? So even the inverses of these, we know them, they will follow the same sign. So cosec, sec, and then cotangent. So if we come to the second quadrant, we're going to have sine here, theta, is equal to, because here it's S, okay? All students take calculus, okay? And so sine here, because we've mentioned it, it'll be positive. Cosine theta will be negative. Tan theta here will be negative, right? Here we see that we say take, which is tangent. So we can say that sine theta will be negative. Cos theta will be negative. Tan theta will be positive because that's the one that we've mentioned. All right, what about this one here? We can say that sine theta will be negative. Cos theta will be positive. Tan theta will be negative in this quadrant. Okay, so normally we use what we call reference angles when we are trying to find the angle in these of the value in these quadrants. So how do we find the reference angle? Reference angle is the angle between the terminal ray and the x-axis. So what's the terminal ray? It's this one. When you have your angle like that, this is angle. Like if you have your angle like that, what will be your reference angle? The reference angle is going to be here. Okay, this angle here. And so you find that some will tell you that the reference angle in first quadrant is actually equal to, reference angle here will be equal to theta. So the angle itself here will be equal to the reference angle. So for example, if I have another one here, and then it's theta 2, so reference angle for this one will still be theta 2, right? But situation changes when I come to, let's say here, okay, I come here, and I'm looking for my reference angle. Remember, this would be maybe 120 degrees, right? If this is 120 degrees, because we measure angles from here. So if it's this is 120 degrees, what is the reference angle here? Because theta is 120. Okay, it'll be this angle here. That will be your reference angle. But what is this angle here? This angle will be 180 minus theta. So here we have 180 minus theta. Okay, then we come to this one here. We go around. We come to another angle here. Let's say the angle is there. This is theta. Okay, theta meaning it's coming from here to there. Okay, and the terminal ray is here. So what is this angle? It's here. That's the reference angle. So what will be that angle? That angle will be this angle here minus what? Minus 180. Okay, so this angle minus 180 will give us this. So in this region here, it will be theta itself minus 180. Or you can actually know how to get around this. You don't have to memorize this. You can actually work it out. Because this will be like, you know that this is 180, and then you just do the remnants of this one. So this is theta minus 180, because it's more than 180. Right. What about if this angle comes over and is here in the fourth quadrant? Where is the reference angle? Remember, we said it's between the x-axis and the terminal ray. So this is the reference angle, right? But what is the angle itself? The angle itself will be this thing coming all the way to here. Okay, coming all the way from here to there. That's your theta. So how can we find this angle? This angle is going to be R is equal to 360 minus theta, because that's your theta here. This one will be R is equal to that. That one is R. I've used R because that's what I want to use. So that's R is equal to theta minus 180. The reference angle here is equal to 360 minus theta. There is going to be, but you have to know what's going on. I think that's what is very important. It's not to really memorize this. It's to know what's going on. If you're looking for a reference angle here, it'll be from the x-axis to the terminal ray. If you're looking for something here, it'll be from here to there. Let me get a different color. This is the reference angle here. So you should be able to know how to work it out. This is the reference angle here. What about here? It's the terminal ray and the x-axis. That's the reference angle. What about here? It'll be that one here, x-axis and the terminal ray. So you have to know how to calculate this. Could be, if you're good at memorizing, you memorize these formulas. Okay? If not, it's still easy. You can still work it out. Okay? Remember, this is 90, that's 90, that's 90, that's 90. So you can actually break it down and be able to get this angle. All right. So these are crucial for understanding, being able to solve completely trigonometric equations. Otherwise, without this knowledge, you wouldn't be able to put it all together.